So question 12, I have done this multiple times and I keep making plus minus errors. And then I finally realized that the first time I did it, I was right, but the answer's got a plus minus error in it. So, right. Look, where we start with, we've got our auxiliary equation. It gives us a complex root. And so we got a cos 3x plus b sine 3x. No problem there. Issue, the sine x and the sine 3x and the sine 3x match. So we go through that we can't just have the lambda cos 3x mu sine 3x. We need the extra x in it. Now it's the differentiating in this that I kept going wrong in, but through having to do it lots of times, even though I didn't need to, I actually found out I was being more accurate if I took the factor of x out and just doing this as a product rule here. Because then if you differentiate the first bit, that just disappears, and I just write down my bracket, and that's a sine 3x. But if I keep the x and differentiate the other bit, well, cos goes to the minus sine, and the sine stays positive. And so I've got that there. That's not y, that's dy by dx now then. So now, to do the second derivative, I can have the same idea. Well, look, we've got to do that bit there first of all. So the cos is going to go to a minus 3 sine 3x. This sine stays positive, so I've got 3 mu cos 3x. I'll do the same trick. I'll differentiate that thing, which means I'm just going to write down the bracket. 3 mu cos 3x. And now I've got x times by what this bracket differentiates to give. So the sine goes to a cos. I've got 3 times 3 is 9, and that's a cos 3x there. And then this cos goes to a minus sine as well then, so minus 9 mu sine 3x. And we do tidy this up, so we've got minus 6 lambda sine 3x is here. And I'm convinced here that there are 6 mu cos 3x's there. I say I'm convinced because in the on the solution bank they cancel out, and that's so I'm convinced that's positive now then. And then we've got minus 9 lambda x cos 3x and minus 9 mu x sine 3x. Now we want this to equal, no, that's what the second derivative is. That's what the second derivative is. Right, so there's your second derivative. Now what we're doing is we've got d2y by dx squared plus 9y. So that is all of that bit there, being very sloppy now because I don't want to do it wrong again, plus 9y. Now 9y is 9 lambda x cos 3x plus 9 mu x sine 3x. So all of that's all just cancelling out, and we want minus 6 lambda sine 3x plus 6 mu cos 3x. We want that to equal sine 3x. So it says mu is equal to 0 here, is equal to minus a sixth. I'm going to stop there and do the actual solution, a particular solution on another video because I'm fed up with reading.